All right, so now we're up to 4 electron-dense areas, and the shape we get into here is a tetrahedral. So once we get to 4 shapes, we start to use the third dimension of space, right? Our linear and trigonal planar have both been relatively flat molecules. This tetrahedral is no longer flat. So the way it's most often drawn, I'll do an example here with methane, is with these wedges and these dashes. This wedge here means that this hydrogen is coming out of the board. And this dash means that it's going into the back of the board. These three-dimensional images can be a little bit harder to visualize, especially if you're not familiar with them. I would recommend you just Google PhET, Google PhET molecular geometry. And I'll link it, of course, into Canvas. And this will allow you to explore the shapes and the bond angles. So let's go take a look at this. You have two options with the molecules or the models and the real shape. Let's just start off with the models. We'll hit these X's just to get rid of everything. And so here we have our lone atom, and then we can, on the top right, you can start adding bonds by simply clicking them. So I'll click that single bond, boom. Now we've added one bond, boom. Now we've added two. In the bottom left, we can click the check mark. We can see that we have both molecular geometries as linear. We can add a third bond, boom. Now we're trigonal planar. We could take that bond away and replace it with a lone pair. Now we're electron geometry trigonal planar, molecular geometry bent. We could take that lone pair away, replace it with a bond, and now add a fourth one, right? And so you see, once you add that fourth one, now we're using all three dimensions, right? And so this is kind of what our drawing looks like. You can see that the hydrogen on the top and bottom right are in the plane of the board. And then the two on the bottom left, one is going inside the plane of the board, one is going outside the plane of the board. So that's what's known as the tetrahedral. The tetrahedral is really important. It's the most common shape in your body, because your body is mainly, other than the water, is mainly made out of carbon, and this is carbon's kind of favorite shape, if you will. Again, we have 4 bonds. We need to draw it with a wedges and dashes. That way we're drawing it in its correct three-dimensional shape. The bond angles here are 109.5 degrees, and you can see that in the simulation on the bottom right. If you click that show bond angles, you can see they're all 109.5. So an example of this molecule is methane, CH4, as we've seen, but other molecules as well, such as sulfate. I didn't draw all the lone pairs in for the oxygens, but I'm just going to leave it at that. All right, and then what we can do is we can start thinking about what happens if we replace some of these atoms with lone pairs. So if you look at this chart, you can see what happens there. If we replace one of them with a lone pair, we get trigonal pyramidal. So that looks like we have one lone pair there, lone pair there, lone pair there. And the shapes all make sense, like the words. Like if you think about this, you've got a triangle down there, and then it kind of goes up there. It looks like a triangle type pyramid. So if you think about the shapes, they all make sense. A common example of this molecule is ammonia. NH3. And then again, you can obviously play here. You can take away a bond, boom, add in a lone pair. You can see molecular geometry, trigonal pyramidal. The electron geometry is still considered tetrahedral. Once we take away 2 lone pairs, then we are in the shape known as bent. The way bent molecules are generally drawn is like this, where one of these lone pairs is kind of coming out of the board, and then one is going into the board, but we don't really draw them like that. You just simplify like so. Our most popular example of this is water, H2O. This is a bent molecule. This is sulfate, ammonia, water. And of course, you can take a look at it over here, take away another bond, boom, add in another lone pair. And you can see if you don't look at the lone pairs, the molecule looks like it's bent. Cool.